It began as routine telemetry, a narrowband spike recorded by three independent instruments: the Deep Space Network Array in Canberra, the Juno spacecraft near Jupiter, and the Parker Solar Probe on its inbound orbit. The signal lasted 143 seconds, coherent, structured, and precisely synchronized with the position of the interstellar object known as 3I Atlas. For months, scientists had been tracking it as the most anomalous visitor ever recorded, an object whose trajectory, chemistry, and behavior violated nearly every established model of cometary physics. But until now, every irregularity could still be framed as coincidence. The signal changed that. At 07:16:42 UTC, all three receivers logged an identical modulation pattern centered on 14 and 20 MHz. The hydrogen line, the universal marker long theorized as the natural channel for interstellar communication. The timing left no ambiguity. The transmission began precisely as 3I Atlas crossed the heliographic longitude predicted by JPL's post-perihelion models. No other object occupied that vector, no solar flare, no known spacecraft, nothing except the third interstellar object ever detected in human history. Here's what we know. Since its discovery in July 2025 by the Atlas survey in Chile, 3I Atlas has been an outlier in every measurable sense. Its path is aligned within 5 degrees of the solar ecliptic, a geometric coincidence with odds of less than 1 in 500. Its composition, dominated by nickel and carbon dioxide with almost no water, matches no known cometary class. And during its closest approach to the Sun, data from SOHO and STEREO revealed an abrupt increase in brightness, 7 orders of magnitude faster than expected, followed by a measurable non-gravitational acceleration, the smoking gun of active propulsion. These anomalies led NASA, ESA, and the International Asteroid Warning Network to maintain continuous monitoring, even after perihelion. Radio observatories were instructed to keep an open spectrum watch near the hydrogen frequency. Until now, nothing. Then, during the object's outbound phase, when its reflected light was expected to fade into silence, the signal appeared. The characteristics are extraordinary. The emission was narrowband to within 2 Hertz. It repeated every 1987 seconds with sub-millisecond precision, a modulation pattern inconsistent with any known natural source. Yet the amplitude oscillated with the object's rotation period, matching the 16.2-hour photometric cycle observed before conjunction. In other words, the transmission is spatially locked to the body itself. At present, cross-correlation analysis has ruled out terrestrial interference, solar plasma reflection, and cosmic masers. The probability of coincidental alignment between the hydrogen frequency and the object's position is effectively zero. If confirmed, this would mark the first verified electromagnetic emission of artificial origin from beyond the solar system. But the data are incomplete. The signal terminated abruptly as the object passed behind solar interference. Reacquisition is ongoing, coordinated through JPL, ESA's STRAC network, and Japan's Yasuda station. And here is where the uncertainty begins. The spectrum shows structured phase shifts, not language, not noise, but ordered variation, as if information were embedded in a carrier we do not yet know how to read. Whether it is a beacon, telemetry, or simple reflection remains unclear. All that can be stated with certainty is this: the signal was real, the timing exact, and the source consistent with 3I Atlas. For the first time in history, an interstellar object has responded. What it means, and whether it was meant for us, is the question scientists are now racing to answer. The anomaly emerged not in the light, but in the structure of the signal itself. When the first analysis from the Deep Space Network arrived, researchers expected the usual noise: random peaks shaped by cosmic background and solar interference. Instead, what they found was order. The emission displayed a coherence unmatched by any known astrophysical source. A spectral width of less than 2 Hertz, amplitude modulation locked precisely to 3I Atlas's known rotational phase, and a phase-coded pattern repeating every 1987 seconds. In natural radio astronomy, such precision does not occur spontaneously. Pulsars, quasars, and plasma bursts all exhibit variability, but never such disciplined regularity across multiple instruments. Even the rotation-coupled correlation, which should have weakened with distance and solar interference, remained stable to within microseconds across three observatories. The mathematics refused to collapse into noise. Here lies the fracture. According to orbital dynamics, 3I Atlas should now be coasting inertly through its outbound trajectory, dimming, cooling, silent. Instead, it is emitting an ordered signal at the exact frequency long associated with theoretical interstellar communication. 1420 megahertz, the hydrogen line. This is not a random frequency. It is the one point in the radio spectrum universally quiet in nature, reserved by international convention for cosmic observation. The coincidence is almost too deliberate to ignore, yet too extraordinary to accept. The first hypothesis is physical reflection, sunlight or terrestrial interference bouncing from an unusual surface geometry. It would explain coherence without invoking intention, but the Doppler profile contradicts this. The emission's frequency drift corresponds not to Earth's motion, but to the object's own radial velocity. The signal originates with the body, not from it. The second hypothesis is mechanical interaction, a resonance within the object's metallic composition, producing radio emission as it spins through the solar magnetic field. The theory fits the narrowband characteristic but fails to explain the pulse precision. No natural precession or magnetic torque could generate a timing sequence accurate to thousandths of a second. A third possibility, less comfortable yet mathematically consistent, is that 3I Atlas is performing active transmission, a beacon, telemetry, or some unknown communication system cycling through information states. The structure of its phase modulation implies data compression far beyond stochastic behavior, though no recognizable encoding has been identified. Each model accounts for part of the evidence, none for all of it. The emission's duration, precisely 143 seconds, is long enough for intent, short enough for deniability. It began and ended with no precursor, no decay, no repetition since. The community now faces a paradox, measured in real time, a confirmed interstellar object displaying engineered characteristics without a detectable mechanism. Every explanation fractures against one piece of data or another. Reflection fails geometry. Resonance fails precision. Transmission fails belief. For now, the network remains in continuous watch. As the object recedes from the inner solar system, its distance grows and its signal weakens, but its implications do not. The anomaly stands, measured, verified, unresolved, a question still transmitting through the noise. From the moment the signal was first detected, time ceased to feel abstract. Every minute since has been measured against its pulse, 19.87 seconds of patterned silence, then a flicker of coherence repeating across three observatories. In the control rooms, timing became the only constant. Engineers synchronized their atomic clocks to the object's rotation, ensuring that when 3I Atlas reappears from behind the solar corona, every instrument on Earth and beyond will already be waiting. Right now, the object is 36 million kilometers past the sun's limb, emerging slowly into the field of view of the stereo and GOES coronagraphs. Light from its reflective shell is still too faint to separate from background solar scatter, but the geometry is closing. Each degree of elongation means visibility improves by roughly 2 minutes per day. By the end of the week, it will pass the threshold where direct optical tracking resumes. Until then, observation is blind calculation. Orbit models, Doppler drifts, signal predictions. The scientists wait for confirmation that the orbit still matches expectation. Every previous interstellar visitor vanished into mathematical precision and reappeared exactly where physics said it should. If Atlas does the same, the anomaly will be treated as transient noise, an unexplained but dismissible event. But if its position deviates, even by a fraction of an arcsecond, then the meaning of that 143-second signal changes completely. A small shift could mean propulsion. A larger one could imply control. The next observable window is projected to open when solar interference drops below safe limits for high-gain antennas. At that point, the Deep Space Network will attempt reacquisition. The time between now and then, measured in days, not weeks, is the most critical interval in the mission. During it, every data stream matters. The faint plasma ripples from Parker's solar probe, the particle counts from Juno's magnetometer, the radio noise maps from Canberra. Tiny variations in solar wind could mask or reveal the next transmission. Meanwhile, the sun itself becomes a kind of stage light, blinding and absolute. Beyond its glare, an object the size of a mountain moves silently through the void, carrying data we cannot yet interpret. The instruments hum, the servers record, and time compresses around expectation. Soon, the object will clear the interference zone. Telescopes across Earth's night side will swing toward its predicted coordinates. When that moment arrives, one of two things will happen. The signal will return or the silence will deepen. Either way, continuity will break, and whatever emerges on the other side will redefine what we call observation. Since the first report of the transmission, the flow of information has changed. Daily public briefings from NASA and the International Asteroid Warning Network have ceased, replaced by coordinated statements, short, confirmed, and notably identical. The official position is that the 1420 MHz anomaly is under analysis, a phrase repeated in every release, even as internal data logs confirm that the signal was real, coherent, and received by multiple platforms. In the scientific community, the silence has become almost procedural. Access to the raw telemetry from Juno, Parker, and the Deep Space Network has been restricted to joint review teams under non-disclosure. Requests from universities have been deferred, citing spectrum security. Behind the restraint, a different rhythm is taking hold. Preliminary analyses from European and Japanese observatories show discrepancies in the predicted orbit. The object appears to be several hundred kilometers ahead of the trajectory calculated from pre-signal dynamics. The difference is small, less than 1/10,000th of a degree in apparent position, but it violates the expected post-perihelion motion. For a natural object, this offset should not exist. The data are being refit hourly, each update moving the uncertainty slightly closer to confirmation. Within the institutional framework, contradiction is handled by procedure. Committees form, statements are reviewed, phrasing is adjusted. Statistically significant deviation becomes measurement refinement. Signal repetition becomes recurrence of pattern. The language remains calm, factual, and reversible. But inside control centers, operators have begun to mark time differently. Every 19.87 seconds, instruments still register fluctuations in baseline noise, too faint to call a transmission, too structured to call random. The fracture grows not from hysteria, but from mathematics. The models built to describe gravitational behavior no longer converge when the signal is included. The probability of spontaneous alignment across multiple detectors has fallen below the threshold for coincidence, yet no one can state what mechanism would allow a coherent emission from a tumbling cooling object receding at 55 kilometers per second. Then, late in the observation cycle, a new entry appears in the shared telemetry feed. The GOES-19 coronagraph, operating at low solar elongation, records a transient optical spike synchronized with the 1987-second interval. Not bright enough for a flare, not consistent with reflection. 3 cycles later, the same pattern repeats, phase-locked, spatially fixed to 3i Atlas. No statement follows. Data servers update, then go still. The networks hold their breath. The object has emitted again. Same frequency, same precision, this time with an accompanying flash in visible light. For now, that is all the agencies confirm. The broadcast has resumed. In the weeks since the signal's return, the noise of speculation has quieted into methodical silence. What remains is data, unchanged, unembellished, still resisting explanation. The 1420 MHz emission has been confirmed by every major deep space observatory. its recurrence documented over 7 observation cycles. The optical flash, recorded by GOES 19, aligns precisely with each pulse, yet displays no measurable spectrum of combustion or reflection. Together, they describe a phenomenon that fits no established category, a repeating, energy-stable emission synchronized to the rotation of a confirmed interstellar body. The official consensus remains cautious. The signal is real. Its source is 3I Atlas. Its nature is unknown. Those three statements define the boundary between certainty and interpretation. Everything beyond them, purpose, design, or even coincidence, belongs to a region of physics that does not yet exist. The prevailing scientific stance is procedural humility. Teams across NASA, ESA, and JAXA continue spectral decomposition and phase analysis, searching for correlations with magnetic, thermal, or gravitational events. No correlation has yet been found. The data are intact, but their logic has not emerged. In this atmosphere of measured disbelief, a new discipline has begun to form. It is not astronomy in the traditional sense, nor communication science in its current form. It is the study of anomalies that persist, signals that refuse classification yet remain repeatable. The protocols, written to prevent misinterpretation, now serve as scaffolds for a deeper kind of inquiry. How to study an event when its cause may not be natural and may not be immediate. Beyond the institutions, the object itself continues outward, a silent coordinate in the dark. Its path is known, its signal intermittent, its meaning undetermined. Observatories will follow it until it fades below detection limits, long after its energy ceases to register. By then, the methods refined to track it, the shared timing, the multi-band synchronization, the global data integration will remain. Tools forged for one impossible event, now part of standard observation practice. The discovery has not answered any question. It has simply altered their order. What was once a search for impact risk or compositional anomaly has become a quiet acknowledgement that the universe may observe us in return. For now, 3I Atlas drifts beyond the solar plane, still transmitting at intervals too faint to decode. The instruments stay calibrated, the networks stay open. When it speaks again, science will be listening.